ago and far, far away from our planet, all the way across the universe. A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Watching this fading light, astronomers on Earth noticed a strange infrared signal. It was invisible to the human eye, but could be perceived as heat. After examining the phenomenon with X-ray, radio, optical, and infrared waves, the astrophysics team made a shocking conclusion. It seemed that people had finally seen a newborn magnetar for the first time ever. This magnetar was likely formed after two neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. But I'm getting ahead of myself. How about we first figure out what these novas, magnetars, and neutron stars are? Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. By the way, when a star similar in size to our sun runs out of its fuel, it turns into a white dwarf. It expels most of its outer material, and only the star's hot core remains intact. Such a core usually gets heated up to 180,000 degrees Fahrenheit. A white dwarf is just a bit bigger than our planet, but half as massive as the sun. In other words, these stars are some of the densest objects in the universe. A white dwarf can be 200,000 times denser than the Earth. It usually takes a white dwarf over 1 billion years to cool down. Under certain conditions, such a star can erupt, and this event is called a nova. It's way less bright than a supernova or even a kilonova, which occurs when 2 neutron stars, or a neutron star and a black hole, merge into each other. Anyway, back to a supernova. If a star is large but not massive enough to turn into a black hole, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side to side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. That's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When 2 neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's an exotic form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. Neutron stars are weird and scary, Their interior is a never-ending dance of particles in extreme conditions. It results in unexpected and odd structures. For example, closer to the surface, hundreds of neutrons form blobs. Those are not unlike some weird kind of space nochi. They mold into long chains once you go deeper. Not that you'd ever be able to explore a neutron star from up close. These long chains look like a layer of spaghetti. Underneath, there's a region of even more extreme pressures. That's where our spaghetti turns into lasagna sheets, since we've started on this pasta comparison. Finally, under all these layers, even lasagna loses its form and becomes a shapeless mass. But even in this mass, there are some tube-shaped gaps. And don't they look like ziti? Another thing about neutron stars, they're spinning non-stop. And this spinning is fast, more than several hundred times per second. The fastest spinning neutron star makes more than 700 turns per second. That's 42,000 times per minute. Neutron stars also have incredibly strong magnetic fields. That's why, if there was life on a neutron star, it would be two-dimensional. The star's gravity is so powerful, it'd literally flatten anything on its surface. And if such a star had an atmosphere, it wouldn't spread up further than a foot or so above the surface. But if neutron stars are bizarre and spooky, magnetars are too, perhaps even more so. Thanks to their incredible magnetic pull, these stars would win in the strongest magnetic field competition, hands down. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. But that's not all. Even your molecules would change under the influence of the star's field. In the end, you'd kind of vanish. If a magnetar flew within 100,000 miles from our planet, it'd wipe out the data on every single credit card in the world. Astronomers have seen magnetars before, but they've never witnessed one getting born. After the light was first detected, scientists understood something didn't add up. They compared different kinds of observations. It turned out that the light spotted by the Hubble Space Telescope was 10 times brighter than predicted. This information made the scientists think outside the box. They realized an entirely new phenomenon was going on. The team had several ideas that could explain the bizarre brightness, but the most probable one was also the most eccentric. Before, scientists thought magnetars only appeared after massive stars exploded and left behind super-magnetized neutron stars. But now, they suppose a small number of magnetars may actually appear in a more peaceful way after two neutron stars merge. Scientists only know about no more than 10 magnetars in our home Milky Way galaxy. They don't know for sure what makes these stars so terrifyingly magnetic. Whatever it is, magnetars don't seem to last long. After 10,000 years or so, they return to a more familiar neutron star state. They're still extremely magnetic, super dense, but not so extreme. The closest magnetar people know about is 9,000 light-years away from Earth, in the constellation Carina. Astronomers think the original star was 30 to 40 times the mass of the Sun, which is a really big one. Another magnetar is 18,000 light-years away from our planet. It suddenly started to burst in 2002. Around 80 bursts were recorded within a 4-hour window. After that, the magnetar has never been active again. By the way, the researchers were also immensely excited about seeing a kilonova. It occurred when the two neutron stars supposedly merged. A kilonova is more than 1,000 times brighter than a typical nova. Before, astronomers had only one confirmed and examined event of the kind. But the kilonova recorded in March looked different, and it might allow scientists to explore the diversity they knew nothing about.
Chibilski's star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chibilski's star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien technosignature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chibilski's star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chibilski's star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf-Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova, but this time the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that 2 stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma-ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf-Rayet to produce a gamma-ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only 1/3 the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate. And then, scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. But the dark halo around its middle is a telltale sign of Vega's oblate shape. Spotted. It seems like 2 giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solo star is relatively simple. They're born in vast, gassy areas of space, burn through their fuel, and at some moment, they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only. which is just a blink of an eye in cosmic terms. The lead author of this study was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in a large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system that stood out from the rest. The two stars found there were pretty big and nearly the same size. Together, they make a mass of about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 7.4 miles apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy too. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. They could merge to form one giant star, which would eventually explode into a supernova. Or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 400 million miles away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are 2 stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G-objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now, it seems scientists have discovered 4 more G-objects, and they're all located within 0.13 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually, it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G-objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed. Yet. Have you heard of variable stars? Look up at the sky. We often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine two stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, now has aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds, and it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its aged dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at the moment, but has risen back to life. But this isn't your average zombie, hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it, because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the cluster are mostly made of the same age and type, hobbies, and interests. I guess even they have better social lives than I do. Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the sun, but Earth's entire orbit around the sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.
Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s, when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable, some massive invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way center. and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, it's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless, more like cosmic puffy clouds than anything else. Scientists called them Fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose. And it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere, and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint: gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. a faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super-powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all. Back in 2008, astronomers found a mysterious something orbiting a star called Fomalhaut. This star is very bright and sits about 25 light-years away from us. Trillions of miles, sure, but pretty close in space terms. It's in the constellation Southern Fish, the one that looks like a single fish floating in the southern night sky. It's a small and relatively dim constellation, but Fomalhaut is what makes it so special. In Arabic, this means mouth of the fish, and you might guess where that name comes from. It's the brightest star in the constellation. If you're in the southern hemisphere, you can easily spot Fomalhaut with the naked eye. For people in the northern hemisphere, it's visible in the fall, low on the southern horizon. But this constellation has a beautiful story. The myth says that this fish is the one that saved the deity Dursida, who had fallen into a lake. So it became the symbol of rescue and protection. The fish in Pisces is said to be the offspring of the southern fish, forming a kind of family. At the same time, Fomalhaut is sometimes called the lonely star because it's one of the brightest stars in its part of the sky, but it doesn't have many bright neighbors. Hey, I can relate to that. Nah, just kidding. Fomalhaut is also a young star. It's only about 440 million years old. Now that sounds like a lot, but our Sun, in comparison, is 4.6 billion years old. And finally, it's surrounded by a giant ring of dust and gas. This is called a debris disk. It's like a dust cloud that serves as the birthplace of planets. It's like the Kuiper Belt in our own solar system, where Pluto lives, but on a much grander scale. But then, astronomers noticed something odd about this disk. It wasn't evenly shaped. This means that there's something that influences gravity nearby. A planet, perhaps? And when they took pictures of the disk, they found a faint glowing dot inside it. That was our mysterious gravity center, Fomalhaut b, or how they named it later, Dagon. They immediately thought it was a planet. In 2008, it was a huge deal because scientists captured an actual image of it using the Hubble Space Telescope. Now that's a super rare thing, especially for objects outside our solar system, not to mention such tiny things as planets. And the photos were fascinating. At first, everyone was excited about the new world. Scientists thought that Dagon was a massive planet, something maybe like Jupiter, a gas giant. They even guessed that it had an oval-shaped orbit, which means that it would take about 1,700 years to go around its star just once. It's one of the craziest orbits we've ever seen. But as they kept studying Dagon, they noticed that things don't add up. For starters, they couldn't find it in infrared light. Now, planets that big usually give off heat, and telescopes like Spitzer, which look for heat signals, found nothing. Weird, right? Also, the planet was moving too strangely. Its orbit didn't match what you'd expect if it were shaping the dust ring. So scientists started thinking, maybe it's not a planet at all. And as the doubts creeped in, the hype calmed down. In 2020, they noticed another strange thing about Dagon. It was getting dimmer and spreading out. And well, planets don't usually do that, but clouds of dust do. This led to a new idea. What if Dagon isn't a planet, but the result of a massive collision. Imagine two big chunks of ice or rock smashing into each other at incredible speeds. That's what they think happened here, a giant space crash that led to lots of debris. That's how it got officially removed from the list of exoplanets. But then, in 2023, the new James Webb Space Telescope, which is even more powerful than Hubble, decided to take a closer look at Dagon. And when scientists looked at the data, they jumped back into the previous debates. Wait, it might be the planet after all. All this scientific back and forth led to Dagon getting dubbed the zombie planet. But after a while, astronomers finally found the middle ground. Dagon really turned out to be a dust cloud that's slowly disappearing, but there could still be hidden planets in the system. There's another ring of dust closer to the star that might be shaped by an unseen planet. There are many mysterious weird planets out there. Trace 2b orbits a star 750 light-years away from Earth, much farther out than our Dagon. It's in a region of the sky that's been heavily studied by planet hunters. It was first discovered in 2006 by the Transatlantic Exoplanet Survey, an observatory with a bunch of cool telescopes that are used to find planets. They use a witty method for it. They observe the stars, and when they see unexpected dips in brightness, that means that something must be passing in front of the star, making it a wee bit darker. This is called the transit method of the planet discovery. When Trace 2b was spotted that way, scientists took a closer look and confirmed it. It had a certain gravity pull that caused its star to wobble. But that also means that the planet should be gigantic, probably a gas giant like Jupiter or Saturn. But, unlike Jupiter, Trace 2b is much closer to its star. This makes it a special type of a planet called hot Jupiter. That's what we call gas giants that orbit so close to their stars that their atmospheres are scorched to extreme temperatures. Imagine if Jupiter was not only horrifyingly massive, but also almost burning. This planet is tidally locked to its star. This means that it always faces the sun with one side, just like we can only see one side of our moon. Its day side is blisteringly hot, but even the cooler night side has temperatures around 2,900 degrees Fahrenheit. But there was something very eerie about this new world. What really made it stand out was its albedo, a measure of how much light the planet reflects. Most planets, like Jupiter or even Earth, reflect a good amount of light thanks to clouds, ice, and other stuff. This is what allows us to see those planets after all. But Trace 2b is almost completely black. For some reason, it reflects less than 1% of the light that hits it. It's darker than coal or fresh asphalt. So, why is that? After some thought, astronomers think it might be because of its atmosphere. Jupiter has bright reflective clouds of a gas called ammonia, but Trace 2b probably doesn't have those. Since it's so close to its star, they'd burn up and get stripped away. So, its atmosphere might be made up of chemicals like sodium, potassium, or titanium oxide. All of this stuff absorbs a lot of light, and if you look directly at that planet, you'd see it almost as a black hole. What's even more horrifying is that if you were floating in it, since it doesn't have a solid surface, these elements could make the sky above look like an endless void, even if it's daytime. Though you'd probably still see its star, even it would be completely surrounded by blackness, like light at the end of a tunnel. In that case, shouldn't it be completely invisible? Well, it kind of is, but it also emits a faint red glow, likely due to its scorching high temperature. And even though scientists have studied Trace 2b for years, some questions remain unanswered. Why is it the darkest planet we've ever found? Is it possible that there are some unknown chemicals in its atmosphere? What hides beneath the darkness? These Jupiter-like planets are often crazy, like WASP 76b, for example. This is another gas giant located about 640 light-years away, this time in the constellation Pisces. Just like Trace 2b, this exoplanet is tidally locked. One side has a temperature of over 4,000 degrees Fahrenheit, while the other side remains in constant darkness. But what's crazy about it is that the extreme heat on the day side vaporizes metals like iron. The planet has insanely strong winds, and they blow this molten iron to the colder side. And you guessed it, the iron gets solid under colder temperatures, and we end up with a horrifying iron rain. All this stuff sounds like science fiction, but it's real, waiting to be explored.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new Sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the Sun and gets its mass. Now we have 2 suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having 2 centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining ex-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our 2-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators.
Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or a GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how big or bright it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, Researchers concluded that Polaris b is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories have been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis Earth spins around and extended it over 300 light-years past the North Pole, at the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times, and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South Poles won't always point towards the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the fifth brightest star in the night sky and the second brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it'll regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old star system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 15-inch refractor, and it happened again in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are two areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution.
Right after its creation, the cosmos was shrouded in darkness. I mean, I wasn't there, but that's what most scientists are thinking. All of the stars were hidden behind a thick cloud of primordial gases. Then, all of a sudden, something cleared up this fog, and the universe started shining as it finally woke up. But how did this happen? 8 faint, recently discovered galaxies might hold the answer. The Big Bang created our world around 13.8 billion years ago. At first, it was just a super hot and chaotic boiling soup of particles. But over time, things cooled down, and particles could finally stick to each other. That's how the atoms appeared. Some helium, but mostly hydrogen, the very first element. And these first elements started creating thick gas clouds, which were very opaque. Then the first stars started forming. They were incredibly bright, emitting lots of light, including ultraviolet radiation. But even though these stars were shining, much of their light couldn't travel far because of that nasty hydrogen fog. The gas clouds absorbed and scattered any little light particles around. It was like the light was trapped around the stars. The Dark Ages lasted for hundreds of millions of years. Then, everything changed. Recently, the James Webb Space Telescope has spotted ancient dwarf galaxies from that epoch. Turns out, they're the ones we should be thanking for lighting up the universe. Back then, they were filled with early stars. These stars emitted tons of radiation that was so powerful that it managed not to just overcome, but break apart the hydrogen atoms in the fog. It turned them into charged particles, like particles that carry a little bit of electricity called ions. Little by little, the fog was cleared away. This process of clearing out the fog is called reionization, and this beautiful time is known as the epoch of reionization. Finally, the light was able to travel to all corners of the universe, which was a game changer, just like humans' Age of Enlightenment. To find these little igniters, astronomers used a technique called gravitational lensing. Imagine light traveling through space like a straight beam. But just like everything in our world, even time, light obeys gravity. If it's too strong, it'll literally bend the light beams. So when the beams pass near a massive object, the object's gravity pulls on them, curling and twisting their path. That's why black holes look so creepy, as they stretch stars and space around them like some whirlpools. But it's not that creepy. A regular glass or magnifying glass does something similar, hence the name gravitational lensing. When the lensing object is horrifyingly massive, it bends the light into multiple images of the same object, creating a creepy and mesmerizing structure called an Einstein ring. But if it's not that big, then the bending is less dramatic, and it just slightly distorts the shape of the background object, making it look kinda stretched. Gravitational lensing also helps scientists study things like the spooky dark matter. If the light looks stretched, and it's not just because of some obvious massive objects nearby, then it might be something invisible and heavy bending it. Since these 8 galaxies were too faint, no wonder they're almost as old as my unread emails. Scientists had to use these gravity tricks to observe them. The team studied light from galaxies that are over 13 billion years old. Finally, they focused on a galaxy cluster called Abell 2744, also known as Pandora's Cluster. And these findings helped them understand how even little fellas played a huge role in transforming the early universe. The James Webb Telescope is an incredible tool, and soon it might help us look at even earlier times, at the cosmic dawn, when the universe was only several millions of years old. Another great tool, called the Roman Space Telescope, is going to help it. It's also possible that these galaxies weren't the only helpers in this entire saga. These early massive stars were absolutely terrifying. They just don't make them like that anymore. Some estimates suggest they were 30 to 300 times more massive than our Sun, and millions of times brighter. Modern stars have some heavier elements in them, but back then they used only the stuff available, hydrogen and helium, which is why they were so hot and shiny. But they also had very short lifespans, lasting just a few million years. For example, our Sun is 4.6 billion years old and is still going strong, thankfully. At the end of their lives, they went supernova. These colorful bursts of energy were so strong that they forged the first heavier elements in our world and spread them across the universe, planting first seeds for the future planets. Meanwhile, the stars themselves didn't just disappear. They collapsed under their own gravity, creating the first black holes. Now, the black holes are also known for producing insane amounts of radiation, so it's possible that they might have helped speed up the clearing of the fog. Ironically, they help the universe shine brighter while sucking up the light at the same time. Recent discoveries show that black holes might be much older than we used to believe. They probably helped new stars and galaxies form. They were millions or even billions of times the mass of the Sun. The James Webb Telescope has already found a pair of early quasars. That's what we call the bright centers of galaxies powered by supermassive black holes. It's a curious pair of quasars that are merging just 900 million years after the Big Bang. This might be the earliest and most distant pair of merging quasars ever found. The telescope has also been studying things that are called cosmic lighthouses. In scientific language, they're pulsars. Pulsars are super-dense remnants of massive stars. They form from stars that were once 4 to 8 times more massive than our Sun. One of the greatest things about them is how fast they spin. They're one of the fastest objects in the universe. They might do around 700 rotations in just 1 second. They got their name because they behave like lighthouses, basically flickering radio waves. These beams of radiation sweep across the sky, creating a pulse-like signal that we detect. Now, a star basically works like this. There's nuclear fusion happening inside of its core. Atoms get fused in each other, move at crazy speeds, bump, all meanwhile releasing an unbelievable amount of energy. That's why they emit tons of light and heat. Of course, all this pressure tries to push outward, sweating like crazy to expand a star. The greatest the fusion is, the more powerful and insane the star gets. On the other hand, there's gravity that's pulling inward, trying to compress the star and keep it a nice small dense ball. As long as there's balance, the star keeps living, but when it gets old and spends all of its nuclear fuel, it becomes too weak to generate the energy it needs and can't fight against gravity anymore. That's when it basically collapses under its own weight, going supernova. What's left behind is the star's core, but now it's crushed down to an incredibly small size, about 12 to 17 miles across. It's roughly the size of a city. This dense core is known as a neutron star. The material in a neutron star is so dense that just a teaspoon of it would weigh as much as 4 billion tons, like 10,000 Empire State Buildings. And all this collapse sets off a trigger, causing the neutron star to spin super fast, creating a pulsar. It's kind of like when an ice skater spins faster when they pull their arms in. Pulsars often have a smaller star friend orbiting them, although it's not always a friendly relationship. Not long ago, astronomers discovered a pulsar that was surrounded by lots of energetic material for some reason. They realized that all this material was the remnants of another much larger star. Turns out, the pulsar had been slowly destroying its friend with its terrifying radiation and particles until it basically ate the neighbor away. It's similar to how a black widow spider consumes its mate. So, systems like this were called black widow pulsars. In any case, these lighthouses most likely help the reionization process as well. A long time ago, they could be very energetic stars in small galaxies and could emit enough radiation to transform the early universe. The James Webb Telescope's mission is to find more of these lighthouses and see what role they played in the universe's evolution.
Is there a giant mega-sun in the center of our Milky Way? Scientists actually thought so for a while because it's the brightest place in the galaxy. It has millions of stars packed into a small area. This area is called the gigantic bulge. The gigantic bulge has millions more stars per light year than any other part of the galaxy. It can be 10 million times denser than our part of the neighborhood. In some cases, stars in this region are only 5 light days apart. That's like if there was another star in our solar system a bit further away than Pluto on a space scale. But why is this place so dense? When galaxies form, a lot of gas and dust come together under the force of gravity. This material gathers up and eventually forms stars. Gravity and angular momentum balance out, and it starts looking like a flat disk with a pretty bright, bulging, dense core. The stars live their comfy lives, and once they get to the finishing line, they collapse under their own huge weight. Then, the black hole forms. Black holes love to eat everything around them, and the more they eat, the bigger they get. And what place is more perfect for a fine dinner than the galaxy center, where all the space stuff is packed together? So it starts eating surrounding gas and dust, forming an accretion disk. As this material spirals into the black hole, it heats up and emits a lot of energy, which makes the center of the galaxy even brighter. That's why you can find both supermassive black holes and galactic bulges in the centers of all galaxies. The galactic bulge at the center of the Milky Way looks a bit like an ellipse. That's a classical bulge. Stars aren't like our sun. They move randomly in all possible directions and planes. Plus, they all move at different speeds. So gravity is going crazy there, and this makes the bulge look more like a sphere, or an ellipse. Since they were the first ones to form, they have some of the most ancient stars in our galaxy. But there are also some places of star formations and lots of younger, massive stars that are less than 100 million years old. As we move farther away from the center, things get a bit calmer. Stars start rotating uniformly and become stable. Right now, Earth is in one of the Milky Way's spiral arms called the Orion Arm, pretty far away from the galactic bulge. In our part of the neighborhood, stars are usually about 4 or 5 light years apart. This means that most of a galaxy is actually just black, empty space. Our black hole is called Sagittarius A star. It's a monster about 4 million times the mass of our Sun. It's also about 32 million miles in size, almost like the distance between Mercury and the Sun. But don't worry, it's not attracting the Milky Way inside it, and it's not gonna eat us. These black holes are actually super small compared to the entire galaxy, so they can only eat whatever's around. Right now, many stars orbit Sagittarius A star, and even though it emits a huge amount of energy, we can't see its light from Earth without a lot of scientific effort. But why don't we see the center itself? The galactic bulge is so bright that even though it's 26,000 light years away, we should see it shining brightly in our sky. Yet, we don't. Turns out it's all because of space dust. There's a lot of dust between us and the core, and it absorbs most of the visible light. We can only look at the galactic core using other types of light, like near-infrared, gamma ray, and so on. NASA has images of the core in different types of light, and it shows how scarily bright the center is without the dust blocking our view. But not all bright regions are blocked by gas and dust. For example, when we look at dense clusters like the Messier 13, the stars are so close together that they look just like a white spot. Most of our telescopes can't separate them from each other. The satellite galaxy M32, our neighbor near the Andromeda galaxy, has about 84 stars per light year. It's so dense that stars can't be resolved even by the Hubble Space Telescope. To get the idea, our solar system is 2 light years long. We'd see about 168 stars outside our window if we were there. Our closest star is Alpha Centauri. It's about 4 light years away from the Sun. If it was just a couple of light days away, it would shine much brighter than the full moon. So if we somehow managed to survive in crazily dense star regions, the sky would be white all day long. but it's unlikely that we'd make it. As we get closer to the center of the Milky Way, the chances of finding life get super slim. The gravity of stars is going wild with chaotic movements, so there are barely any planets around. On those miracle planets, the radiation from cosmic rays is skyrocketing. Supernova blasts and star collisions nearby become an everyday occasion, and all the gas around makes it basically impossible to breathe or even see properly. At the same time, as we move further away, there are fewer stars around. Elements that are super useful for life, like carbon, oxygen, and iron, are produced by stars, so they also drop. Too much radiation is awful, but too low radiation means that there's not enough energy to support chemical reactions, like photosynthesis. Which is why, if there is extraterrestrial life, it would most likely be somewhere in the middle of different galaxies. But some galaxies get their brightness from a so-called active galactic nucleus. These are extremely energetic regions at the center of some galaxies. They shine much brighter than any stars imaginable, although it mostly shines only in certain parts of the electromagnetic spectrum. The brightness comes not from the stars, but from the accretion disk around their supermassive black holes. As the material slowly falls into a black hole, it gathers around it and creates this flat, spinning disk of gas, dust, and other stuff. Since the gravity and friction there are insane, this disk heats up and starts emitting enormous amounts of energy. Also, this disk spins incredibly fast, almost at the speed of light. Because of that, collisions there happen all the time, and they're unimaginably powerful. They release even bigger amounts of energy. Most galaxies don't have an AGN. Those that do, like the galaxy M87 in the Virgo constellation, are called active galaxies. There are also different types of AGNs: the Seyfert galaxies, radio galaxies, and finally, the winners of our space brightness competition, quasars. Imagine things so bright that they can outshine the entire galaxy they belong to. Quasars are a specific type of active galactic nucleus, the most extreme and luminous form. They belong to the supermassive black holes, the biggest ones in our universe. Quasars are like a combination of several things. First, they're the brightest accretion disks in our world, because of their behemoth black holes eating everything around. But they have some cool features. For example, they have powerful jets of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets add up to the brightness of the quasar, although they can only be seen in radio wavelengths. The energy they emit is so intense that they can be seen billions of light years away. However, the nearest quasar to us is 600 million light years away, so we can't see them with backyard telescopes. So, when we look at a galaxy through a telescope, we usually see only the brighter core, not the outer parts. Unfortunately, our eyes just aren't made to see things like the active galactic nucleus. So, these stars are the brightest things we can see. But what a beautiful sight it is. The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from two of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the Sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheroidal beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles, the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. and, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time. An asteroid broke off the moon and now it's super close to Earth. Does it pose a danger to us? Kama'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater is about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, It's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth. Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chang'e, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon, and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
Astronomers have been asking one question for decades. Is space really as black as we think it is? Well, NASA's New Horizons space mission might have just given us the answer. After exploring Pluto, the spacecraft kept going and is now billions of miles away from Earth. This means it's far from all the light pollution we get from sources like the sun and dust particles around our planet. Scientists used the spacecraft's simple camera to take images of what looked like incredibly boring blank space, free of bright stars or anything else that could scatter light back into the camera. They then processed these images to remove all known sources of visible light. Once they'd removed the light from stars, plus scattered light from the Milky Way, they were left with light coming in from beyond our own galaxy. But here's the surprising part. They found that there was still plenty of unexplained light. In fact, it was about equal to all the light coming in from the known galaxies. That means there's just as much light outside of galaxies as inside them. So, where does all this light come from? Well, it could be coming from sources we haven't yet discovered, like small, faint dwarf galaxies or unknown phenomena out in the universe. Or it could be associated with dark matter, which is still a mystery to scientists. With this groundbreaking research, we can say that space isn't as dark as we know it. What if we take all the light from the stars and galaxies out there and throw in some gas and dust clouds? What color do we get? Beige. This leads us to another question. Do we still need the sun if our space is colorful? And the short answer is, yes, we do. The colors of space are a result of the interactions of light with different celestial objects, such as stars, galaxies, and gas clouds. While these colors are fascinating to observe, they do not provide the energy life on Earth needs to survive. There you go. Don't expect to see the color of the sky in space.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
A recent study suggests the universe is similar to your brain, only at a much, much larger scale. The brain's neural network contains about 86 billion neurons. The observable universe has at least 100 billion galaxies. Both galaxies and neurons have a similar structure. It's a complex web of nodes linking up long thread-like fibers. But in each of these systems, the fibers make up a mere 30% of the total mass, and the remaining 70% are either water in the brain or dark energy in the universe. The ways that galaxies and webs of neurons connect with one another are surprisingly similar. In both cases, the process follows the same physical principles. At the same time, some researchers claim the resemblance between the brain and the universe is only superficial. Your mind perceives tiny details and joins them, and then it comes up with a conclusion that has nothing in common with reality, like the brain is a mini-universe. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. To turn Earth into a black hole, you'd have to squeeze it until it was the size of a marble. And if you wanted the sun to become a black hole, you'd have to compress it until it's no more than 4 miles across. A starburst galaxy is a galaxy that's forming tons of new stars at breakneck speed. It usually happens after 2 galaxies merge into one. While Earth has only one natural satellite, Jupiter is surrounded by at least 79 moons. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A supermassive black hole 250 million light-years away from Earth hums the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. Planet Kelt 9b is 670 light-years away from Earth. It's an ultra-hot Jupiter. Those are giant, scorching hot planets with a mass similar to that of Jupiter. On Kelt 9b, the heat is so great on the day side of the planet, it tears molecules apart. Any liquid floating in outer space forms itself into a sphere. It also happens in low Earth orbit. Our home Milky Way galaxy is more than 105,000 light-years across. All the planets of the solar system would fit between Earth and the Moon with some space to spare. Black holes spaghettify things. It happens when something gets past the point of no return. Then the black hole's gravitational pull starts to stretch this object in one direction and squeeze in another. The first celestial body that astronomers identified as a spiral was the Whirlpool Galaxy. Its long arms are made of gas and stars, and everything is sprinkled with fine space dust. When you're on Earth, you can only see 5% of the universe. A star coming too close to a black hole can be torn apart by its gravitational force. WASP-12b is a giant planet 1,400 light-years away from Earth. It's made up mostly of gas. Unfortunately, the planet is doomed. It orbits too close to its parent star. In about 10 million years, WASP-12b will be swallowed by its greedy sun. Our Milky Way galaxy and the Andromeda galaxy, its closest neighbor, are going to meet in a bit less than 4 billion years. When they collide, they'll form one huge elliptical galaxy. One of Saturn's smaller moons, Enceladus, reflects almost 90% of the sun's light. It makes the moon one of the brightest objects in the solar system. But since it reflects sunlight instead of absorbing it, the temperatures on Enceladus's icy surface drop to -330 degrees Fahrenheit. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest. If you were standing on top of Olympus Mons, its slopes would be hidden by the planet's curvature. In our solar system, Mercury and Venus are the only 2 planets without moons. Scientists who are planning to send droids to Mars want to load the machines with lots of heavy equipment. The droids will also be built from stronger materials, all because of the relatively low gravity on the red planet. Everything on Mars is almost 3 times lighter than on Earth. Pluto's largest moon is half the size of the dwarf planet itself. This makes Charon, that's the moon's name, the largest known satellite relative to its parent size. There are 3 golf balls on the moon. They were launched during the Apollo 14 mission. Mathematicians claim white holes might exist, even though scientists haven't found one yet. If you came across a white hole, you wouldn't be able to enter it from the outside, but you'd see light and matter escaping from within. On our planet, one full rotation takes 1 day, but the Sun is so enormous that it needs 25 to 35 Earth days to make one rotation. The Moon is not a perfect sphere. It's shaped more like an egg because of the Earth's gravity. Spacesuits protect astronauts from huge temperature differences during spacewalks, from negative 250 degrees Fahrenheit to positive 250 degrees Fahrenheit. A neutron star gets born after a supernova collapses. After birth, it rotates extremely fast, about 60 times per second. But this rate can sometimes grow up to 600 times per second. In 2007, astronomers started to receive ultra-bright and ultra-strong radio signals. Named fast radio bursts, they were coming from somewhere billions of light years away. When astronauts are in space, they often see random flashes of light. They occur when cosmic rays hit the optic nerve in the eye. If you traveled around Pluto's equator, it would be the same distance as walking from Rome to New York City. If you visited GJ 504b, a planet located a mere 57 light-years away from Earth, you'd see that the planet is glowing. It's because of the heat left after its formation. The planet's color is a dull magenta, like a dark cherry blossom. Jupiter has the shortest day of all the planets in the solar system. It lasts just 9 hours and 55 minutes. Because of its fast rotation, Jupiter isn't a perfect sphere. It's a bit flattened. Venus has more volcanoes than any other planet in the solar system. There are at least 1,600 of them on the planet's surface, but most of them are extinct. Mercury has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. Nuclear pasta found inside neutron stars is believed to be the strongest substance in the universe. These noodles of neutrons can be 10 billion times stronger than steel. Some astronomers believe black holes might have no event horizon, aka the point of no return. Instead, there might be the apparent horizon. It can only trap stuff for some time. Later, matter or energy escapes, but in a different form. Each Apollo mission needed 15 spacesuits. Each member of the 3-person main crew needed 3 suits. One was for training, the second for flight, and there was also a backup suit in case something went wrong with the flight suit. And each of the 3 members of the backup crew had 2 spacesuits, one for training and one for flight. Scientists believe Mercury might still have a partially molten core. It could explain why the planet has a magnetic field, even if it's just 1% as strong as Earth's. Dust storms on Mars are the most severe in the whole solar system. They can be raging for months on end. On planet Kepler 16b, which is 245 light-years away from Earth, not one, but 2 suns set over the horizon. The planet is as massive as our Saturn, but has a higher density. It takes 45 minutes to put on a spacesuit. After it's done, an astronaut needs another hour to adapt to new conditions. Earth-grazing fireballs are bright meteors that enter the Earth's atmosphere, but then leave it again. Triton, one of Neptune's moons, orbits the planet backward. It's the only big moon of any known planet to do so. Triton is also gradually getting closer to Neptune. Experts think that, eventually, the moon will be pulled apart by Neptune's gravity, and then it'll form a ring around the gas giant. Dwarf planet Haumea, which is further from Earth than Neptune, is truly bizarre. It's orbiting in the Kuiper Belt, a donut-shaped ring of ice objects circling the Sun. Haumea has 2 moons, a weirdly elongated shape, and a day that lasts 4 Earth hours. But the coolest thing, the dwarf planet is surrounded by incredibly thin rings. They're likely the result of an ancient collision. It takes Neptune almost 165 Earth years to make one full orbit around the Sun. In other words, since the gas giant was discovered in 1846, it's only circled the Sun once.
Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the Red Planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guessed that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the Smoking Hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on Smoking Hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right. But experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the Smoking Hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the Smoking Hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now, it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The Smoking Hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the Smoking Hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the Smoking Hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. But you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity. Curiosity, the rover has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history. Where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now, it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
Have you ever seen the other side of the moon? Ah, I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare. the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had 2 teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually 2 tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes, traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So stay tuned for new exciting research and discoveries. While some astronomical events are pretty common, there are those which occur only once a year or once in 100 years. Let's have a look at the coolest and rarest events we might be able to see with our own eyes. The first amazing celestial event on our list is the Perseid meteor shower that will take place from the 17th of July to the 24th of August 2024. This event is going to be one of the most vibrant of the year. At its peak, between the 12th and 13th of August, you might see up to 100 meteors per hour, if you're in a dark place, that is. This meteor shower is caused by debris from the comet Swift-Tuttle. As meteors streak through Earth's atmosphere, they often leave behind long wakes of light and color. The perfect time for watching this cosmic show is right before dawn. On the 2nd of October 2024, we'll be able to watch a ring of fire solar eclipse. Its scientific name is an annular eclipse, and it occurs when the Moon is slightly farther away from our planet. In this case, when the disks of the Moon and the Sun align, the Moon's shadow doesn't completely block the Sun's light. As a result, you can see a ring of sunlight around the Moon. This time, the ring of fire will be visible in southern Chile and southern Argentina, so book your flights early. Another cool event that will occur this October is the Draconid meteor shower. During this event, meteors are more likely to fly in the evening hours than in the early morning. This is usually a slow shower, producing just a handful of meteors per hour. On the other hand, astronomers speak of a rare fiery Draco, which has been known to send many hundreds of meteors across the sky within a single hour. Are we going to get lucky this year? Time will show. Starting from the 12th of October and for the following week, you'll have a chance to see a comet passing by our planet. Now, even though this nearly unpronounceably named big boy will be about 40 million miles away from the Earth at its closest point, you might be able to see it with the unaided eye. Now, comets have a reputation of being quite unpredictable. Most of these dusty, icy space bodies are thought to have originated on the outskirts of the solar system millions of years ago, and there they spent most of their time in the dark, inert and unnoticed, like me in middle school. Now, some of them come closer to the Sun, and many experts already forecast a fantastic celestial spectacle in October. So if you missed the meteor showers we've talked about, you'll be able to catch up. Orionid meteor showers will keep going from the 26th of September till the 22nd of November 2024. Sometimes this event can produce from 40 to 70 meteors per hour, but recently the maximum number was lower, from 20 to 30 visible meteors. And the final event for this year is going to be the Geminid meteor shower. And let me tell you, this event is going to be breathtaking. Astronomers claim that this meteor shower is one of the best of the year because of bright visible meteors. Around 120 shooting stars are likely to streak across the sky per hour. Interestingly, while most meteor showers come from comets consisting of dust and ice, the Geminids originate from a rocky asteroid. Scientists still don't know how to classify this asteroid since it has a tail and brightens as it comes closer to the Sun, just like a comet. On the other hand, recently, astronomers have discovered that the asteroid's tail is not made up of dust, but of sodium gas. Alright, let's travel farther into the future. In 2029, we'll witness the darkest lunar eclipse of the century. A lunar eclipse occurs when our natural satellite completely hides in Earth's shadow. Sometimes, when it happens, the moon can look bright red. Normally, the closer the moon is to the center of the shadow of our planet, the darker the eclipse is. And, according to experts, the eclipse on June 26, 2029 will be extremely dark. It will last for about an hour and 42 minutes and will be the most visible in South America. So, again, don't forget to book your tickets. A supermoon that's also the second full moon to occur within 1 month is known as a blue supermoon. Such supermoons don't follow a regular schedule and occur every 10 years or so. According to NASA, the next blue supermoons will happen in January and March 2037. Then, 3 years later, in 2040, we'll witness the Parade of Planets, when 5 planets of the solar system — Mercury, Venus, Mars, Jupiter, and Saturn — will line up. Of course, it won't be a perfectly straight line, but it will still be a pretty impressive view. Some planets, like Venus and Jupiter, can be clearly observed even in big cities and with the unaided eye. But during the Parade of Planets, you'll be able to see more, so perhaps it's time to stock up on telescopes. The brightest supermoon of the 21st century will occur in 2052. The thing is, the orbit of our natural satellite isn't perfectly round. The moon follows an elliptical path while traveling around Earth. That's why there are 2 points closest to Earth, called the perigee, and the farthest, known as the apogee. On the 6th of December 2052, we'll see a stunning supermoon. Our satellite will be around 221,000 miles away from our planet, which is closer than normally. In 2060, we're likely to see a comet called 15P Finlay. It will be one of the closest comets to approach our planet in the last 100 years. It'll fly by at a distance of around 3.1 million miles. And here's the thing. Every time a comet comes close to the Sun, it heats up and starts emitting gases and dust, looking like a little star. Thanks to solar winds, it also gets a beautiful long tail. And the closer to Earth a comet passes, the brighter it looks in the sky. So get ready for a breathtaking show. In 2084, something known as an Earth eclipse will occur, becoming one of the most exciting events of the 21st century. Sadly, we won't be able to see this celestial spectacle from Earth, obviously, but we might be able to admire it from Mars. During this event, the Moon and Earth will pass by the Sun, looking like dark silhouettes. Such an event is known as a planetary transit, something like a solar eclipse, but with other planets instead of the Moon. Now, in 2100, for those of us still here, the North Star will be the closest to the North Celestial Pole. Sailors have been using this famous star for centuries to figure out where north is. But the funniest thing about this is that this star isn't perfectly aligned with north. The reason is that Earth doesn't have a fixed axis. It rotates in space like a giant spinning top in a process called orbital precession. That's why the North Star doesn't remain in the same place in the sky. It moves, slowly but steadily. But on the 24th of March, 2100, the polar star will finally appear over the true north of our planet. And after that, it'll start moving away again, to return 26,000 years later. So as you can see, it's going to be a truly rare event. Plus, It'll be like a parting gift from the North Star. Since Earth's axis is constantly moving, in around 2,000 years, the North Star will be replaced by another, Gamma Cephalus. So, the close approach in 2100 will be the nearest it will be to our planet for a long, long time. So, I hope you've made notes of the most interesting astronomical events of the next 100 years. The coolest thing is that to witness most of them, you don't even need to buy a telescope. They're going to be visible to the unaided eye. Ooh, look at that! So, Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs, but it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and we are, the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover.
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But Vasco is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and